Rendering in Next.js is the process of converting the code into user interfaces. This process can be done on the server or the user's browser. Developers can decide who should render the component, but at some point they will be limited by the environment. For example, since we don't have a browser on the server, it's impossible to use some of its API, and performing operations like user interactions must be done on the client side. So we end up with the concept of server and client components. React server components will be rendered on the server. They are proper for data fetching, have more security, and are good at keeping sensitive data and logic on the server. Caching, performance, and SEO are other benefits of the server components. On the other hand, client components allow you to write interactive UI that is pre-rendered on the server. It gives you interactivity, so you can use event listener or some hooks like use state or use effect. Also, we have the composition pattern where you can combine both approaches in a way that part of the page would be rendered on the server and part of it in the client. And the ways that they can communicate with each other on the server, client, and bidirectional can be discussed. This video is going to cover server components, client components, and this composition pattern. Alright, server components. I'm going to explain how Next.js rendering works and how it converts React code into HTML so the browsers can show them in their UI. As you can see here, I have a simple React code, and the way that Next.js works is to make an object out of this React that looks like the React tree. This is actually the React tree. As you can see, it has the structure that we can use it to rebuild the HTML out of it. For example, we have a div, which is here as a parent, and then it has some children, which is a button, then the button has a children, which is a text over here. There are some parts of the code missing. For example, I have this onClick, but it's not part of this React or this JavaScript object. We call this object the React Server Component Payload or RSC payload. And after producing it out of the component itself, Next.js will generate an HTML out of it. So by using this payload, we can generate HTML. In this case, it's similar to the original code, but also it will include that React Server Component payload into the output or final HTML, as you can see here. And they usually put it in the self._next_f object, which is an array of all the React Server Component payloads. It's not officially documented, but I figured out of my experience. And the reason that they are generating HTML and putting this payload with the HTML is that on the next step, they're going to use it on the client. Everything that's happened here so far is done on the server. First of all, we have this code, we generate payload, and from the payload, we generate the HTML, and inside that HTML, it embeds that React Server Component payload as well. It's time to send this code or this object to the client, which is the HTML. We send them to the client, as well as some JavaScript files. These JavaScript files are required to make these two things, the HTML and React Server Component payload, alive, as well as some other source code. For example, this onClick that at the beginning I had, it will send them to the client into a different bunch of JavaScript files, not embedded in the HTML. But so far, as soon as we try to open a page, we immediately get the HTML. We can show something to the users, so it boosts the performance, and users can immediately see something. And then to make the HTML alive and make it interactive, we have a phase called hydration. Using the JavaScript from React and this HTML and payload, we do the hydration and we make the HTML alive. So from now on, users can interact with the HTML. Maybe they can, I don't know, click or do whatever they want on the client. There might be some re-rendering. From now on, React will take over and do the stuff on the client or on the browser. This is how it works from React Server Components. For the client component, it's almost similar. Imagine we have a component that has some client-side interactions, for example, click, or using browser APIs, like calling the alert from window. On the server, we don't have window, we don't have alert function, and we cannot have also onClick or these kind of events on the server. So if I try to run it on the Next.js, I will receive an error because I'm using some stuff that doesn't exist on the server. Next.js will give me some errors in advance. I cannot run this code until I add a missing line here. And this is maybe the first time that I'm explaining this directive. We call it use client directive, something that we can add at the top of the page. So if you have any page or component that has something with interactions, something with use state or use effect, or you are using some browser APIs like local storage, like alert, like window size, that they need to be run and executed on the browser, you have to add this use client directive at the top of that file. And the reason that we should add this is Next.js tries to reduce the bundle size as much as possible. So it will not send that JS file next to the HTML and React server components to the clients when they are not required. For example, here I have these utils. I'm importing something, a function from a module here. Imagine I have a module called utils.ts and it's exporting a simple function, and then I'm in the button, I'm importing it. If I don't have this use client, this function is not going to be sent to the client because Nextjs, as I said, is trying to reduce the bundle. If it's not required on the client, it should stay on the server. We should not send any extra JavaScript code to the clients if it's not required. Even though I'm importing it into my button and I'm calling it in the onClick, if I don't use client directive here, this function is not going to be sent to the client anyway. So another benefit that having use client directive at the top of the page brings is to send some bunch of JavaScript that is required to exist on the browser. And now I'm going to show them in action to see how it works, how we can have server components, client components, how they work. So you can see that it's actually doing the same thing that I just explained before. Here I have created a very simple application, consists of a layout, which is a simple layout, doesn't have anything special. And then I have this page. I'm trying to show some simple HTMLs here, like h1 home. Then I have this button, and then I'm having this link pointing to a page called about. And also I have this page about, which is a simple page. So it doesn't have anything special, just a simple text in here. And you can see it's running here. I'm on the page. I have this home, then this button, and then a simple link that will navigate me to the about page. Now I'm going to see how React is generating the HTML for me. If I take a look into the page source by right-clicking and clicking on the view page source, you can see that there are some HTMLs here. It begins with the HTML, then it has a body at some point, maybe here. And then it has all the HTML that I'm generating on the page. Here, for example, h1, and then the button and this link. Let's see, we have this home page, and then the button, and finally we have this link that is converted to A. So as you can see, the HTML is produced and generated on the server, and now I have it on my browser, which is something happened on the server. We call it server-side rendering. And also it is sending some JavaScript objects or JSON objects as the React server component payload in these scripts at the bottom of the page to hydrate the HTML with the React component itself. If you take a look in here, probably we can find them. If I search, for example, for this text, you might see it exists twice. One is inside the HTML, and the second occurrence of this text is here in that payload that I explained. Probably if I go to the network, you can see it better. Let me inspect. I go to the network, I have to refresh. Then for the first request, which is the document itself, if I zoom in it a little, let me make it bigger. You can see that the HTML is here, and then if I scroll down a little, you can see some scripts are injected or added into the HTML at the bottom of the body, and this __next_f, which is a simple array here, has or contains some React server component payloads. In our case, the data that I'm looking for is this one here in this array, and this is a long array, as you can see. And also we can actually copy this because it's a kind of a JSON format. So I can copy this and I can put it into probably text editor. Let's try like this. If I change the language to JSON, I try to format. Well, I have to convert all of these to code, and then probably I can format it. Format the document. There are some formatting issues, but I can do like this to show it, and you can see that it consists of the stuff like React tree structure, like children we have, and also other than that, it will have all the properties that are required to generate that HTML. It means if you pass any property to your component, it will also include it in here. For example, here for this link that I have these attributes like href or prefetch, and href is pointing to about and prefetch is false. Exactly same thing that I have on my page, these properties. I'm not going to explain more about this React server component payload, but in general, I hope you get the idea how it works and how Nextjs is working, but here is an interesting point. Let me inspect here again. I will attach it to the bottom of the page. Okay. Now if I go to the network tab, if I click on the go to about me page, which is a simple link, here I've created it. If I click on this, let's see what happens. It requests for something, not for a document, but it's trying to fetch something called RSC, or React Server Component. And it's actually getting React Server Component payload. Let's take a look into the response. If I detach it again, you can see the response is exactly look like React Server Component. It's not exactly the HTML. It has some like numbers or characters at the beginning. It doesn't look JSON, but it is a payload that React or that library that converts this to HTML will understand. For Next.js, the about page looks like this. By having this payload, it's able to produce this page or this HTML for me. And this happens only if I click and soft navigate to another page. If I try to refresh, let's refresh. This time you can see that it's asking for the HTML because I'm hard refreshing. They're doing it because of the SEO or having server-side rendering. Because for a search engine, for example, this HTML matters. But for navigating or having a better user experience, it's better to get only that small part or that small chunk of React Server Component to generate the HTML. Having the whole HTML alongside of the React Server Component at the bottom is an overhead that we don't need necessarily. Next.js on the client knows how to rebuild the HTML because it's already have all the information to rebuild it, because at the beginning we send them to the client, so there's no need to do an extra job here. So once again, if I go to the home page, I clean the console, I try to navigate to the about page. You can see it only requests for this about, and then question mark RSC, React Server Component, and it gets this response in some payload format. We really don't care about the format and how to interpret it, but it's enough to know that it's required to make this page be visible and be alive and convert it to HTML. So that was it from the React Server Component. And now I'm going to explain the client component. If you take a look into the homepage again, you can see there's a button and it has some interactivity. I can click on it and it has a state actually. I can change the state and you can see it's reflected, or it is causing the button to be re-rendered. Let's take a look into that button. The component is here, the button component, and as you can see, I'm simply using the user state. And since I'm using user state, also I have this on click, it's necessary to have this use client. But if I remove it, let's see. Immediately I will receive an error because it says that you are using user state, but you don't have use client. And if you read the documentation or the error log here, this React hook only works in a client component. So we must have this use client at the top. Now it is working. Now I'm going to add a utility function. Then I will import it into this button and see if that utility function will be sent to the client and we can find it in the JavaScript bundles or not. Let's try to do so. I create a file called utils.ts, and then I simply export a simple const add function that receives two numbers and returns the sum of them. Then in my button component, I will try to import it. Add from utils. Should be like this. Okay. Now I'm going to call this function. Let's call it somewhere like here. Add 1 and 2. As you can see, immediately I get the alert because I'm calling the alert here. But also let's take a look into the network. If we have this add function in the client. If I try to refresh, first I will receive some alert, of course. But if I take a look into the JavaScript files, I believe it should be somewhere here, maybe this one. Let me see if I can find it. I'm going to scroll, not here, probably in another JavaScript file. Okay, over here, you can see it. Let me zoom. You can see this function, this add module is imported, and you can see the body of the function here, and also the button, maybe we can find it. The button is calling it somewhere. Set a state, not here, but over here, yeah. It's converted to some JavaScript, to some Webpack naming representing that module, of course. But you can see the source code does exist on the browser or on the client. And that's because we are using this use client directive on top of the component that we want to be rendered on this client. But if I don't have this, of course, this add function is not going to be sent to the clients. Let's try it. So I remove it from here. And this time I'm going to call this function, this util, and import it into my page. For example, this about page. If I call it here, about me, and then I'm calling this add function 1 and 2. I go to the about, and you can see the result of this add is 3, but it happens on the server. And to prove it, I can inspect again, and this time if I try to find it in the JS files, you should not see it. Let's see if I can find it. I hope I cannot. For sure I will not be able, because it really does not exist on the client, because there's no need to be sent to the client, and Nextjs is smart enough to not send it and make and put it into the bundle. If I go, I'm pretty sure it's not there. I'm not cheating, believe me, but you get the idea. Now I'm going to add some extra examples that we can have on the server, and how we can use some features that it's not possible to have, or is better to not have them on the client. For example, to access a database, the best place is to write those kind of logics, accessing database on the server or on the server components. I will try to get some data from a database here. I have Redis. It's not a database, but it's a cache system. I already have it running. The red is called Redis. Let me show it to you. So here, NoSQL, you can see I have this Redis, and it has some key value. For example, here I have this message consists of hello world value. Now I'm trying to get it into my page on the server, not on the client. So I have this page. I'm pretty sure that it will be run on the server only. Now to do so, what I can do, I have to connect to the Redis, read the data, and after reading the data, I can put it into the HTML or do whatever I want. In this example, I'm going to render it on the page. To save time, I have written some codes already here. I have to import it. Let me import this create client from Redis, like this. And then I'm simply connecting to the Redis here. And then this client, using this client, I can get the values from the Redis. Now I have the value into this constant. And now I can render it somewhere like this. If I go with a P, and if I refresh, let me go to home page, you can see hello world exists on the page. And this is in a way that this part of the code, since it's run on the server, it will never be shown on the client, and it's totally safe to have this kind of code in your application. I also could have some credentials like username and password to connect to the database. For sure, this part is not going to be sent to the client, as well as any part of the codes that are supposed to be only exist on the server. Now it's time to talk about the composition pattern, because in order to have some patterns like data sharing between server components, and maybe between client components, or from server to clients, or combining them together, rendering them inside each other, there are some rules or some patterns that we have to follow. I'm going to talk about them one by one. But before that, I'm going to talk about when we should switch to server component and when we should use client components. And here's in the documentation, you can see that there's a table. They are explaining what is the best place that we can switch between these contexts. For example, we have this server component and client component columns. And in order to have fetching data logics, it's better to have server components, and we can do them on the server. Also, if you have any access to backend resources, you can go with server components. If you have any sensitive information, tokens, APIs, you go with server components. And to reduce the client-side JavaScript, it's better to use server components and keep the codes as much as possible on the server. And to have client components, when we should use them, when you have any kind of interactions like on click or on change or user events, you go with client components. If you have any kind of hooks like use state, use reducer, use effects, you must use client directive on top of your component, otherwise you will receive errors. Also, in order to use the browser APIs like local storage or window functionalities, you must use client components. And this one as well, explaining is the same. Now imagine we have the different components like server components and client components, and now we want to combine them together or to use them together in our application. And one of the first questions that comes into mind is how to share data between server components, because usually we go with patterns like Redux, or we can use context providers. But since context provider itself under the hood is using use a state, we cannot use it on the server. So we have to go with another solution that Next.js offers, and it's nothing other than using fetch API and caching. So if you have any kind of information that you want to share between components, you go with the fetch API if you're getting that information from external APIs, or if you're maybe querying some data from database, you can use cache. So first, let's go with fetch API. So to start with, I have created a file called server. It's a simple server, Node.js server. Simply returns a message or a JSON. We can call it. Let me try it. So if I do the curl with localhost 3001, you can see we received the information here. So let's try to get this information and call this in our server components. I go with the page itself. In my home page, I want to get this information, and to do so, what we can do is to using the fetch API, which is an enhanced version of fetch. I go and call it. Let's try localhost 3001, and probably I have to say the protocol as well, like this. Okay, now I have to await it and put it into a variable, but it would be something that we have to await again and read the information like this, JSON. And now I have the data, and instead of here, I can go with message, data.message. So let's see. As you can see, it immediately gets the data from that server. Let me refresh. And also I'm logging every request that I'm getting. I'm logging, and I'm using console log. I'm writing something to the console. Let's see. And you can see I'm receiving the request. Let's refresh. And on every request that I'm sending, I'm logging, and I'm receiving that request in my server. Let's try again. You can see. And let's see how this fetch API can help us to pass data. The common pattern that I explained before, it says that it's fine to call it multiple times in different places. Instead of passing this data or drilling this data down to your component, you can simply get the data from the original place over and over, because it's going to be cached under the hood. And to do so, I can create a simple component here, const component, that will try to do exactly the same thing, and it will return maybe something. Let's go with the copilot, whatever it gives. Okay, that's fine. I can get rid of this maybe. And now it should be async. And as you can see, I'm getting the same data from the same place. And let's see if it's going to be called. It's going to call our server twice. I will render this component somewhere, and here maybe. That's good. So I have two hello worlds, as you can see, and let's take a look into the console. If I clean the console and if I refresh, you can see it only sends one request, and this is the fetch responsibility because it has cached the information. The first time that we call this API is going to be cached, and second time that in another place in our application, maybe in a component under the hood, way nested in the React tree, we called to get the same data, and it's going to be read from the cached place. So it's totally fine. You can use it, and if you're worried about the caching and revalidation, it has some other options. This fetch API that you can disable this behavior by sending the revalidation, but I'm not going to explain this fetch API now, because we will cover this fetch API in another video in the future. But for now, it's fine that you should just imagine that in order to have to share data between server components, you can go with this pattern. Also, since we are getting some data from an API and we are using fetch, maybe you are getting data from another place, maybe from database. So I have a database. If you remember, it was the Redis, actually, not a database. It is a cache. So I'm getting the user information from the Redis, and I know that the Redis is a cache. There's no need to cache it again because it's already fast. But just imagine that it's a database, and we want to cache the query, whatever to be request. We want to cache it and not calling the same query over and over. But we want to have that information in different places in our application, maybe different components. So I will put a console log here as well to see if this cache is going to be called by users or not. So what I'm going to do is, first of all, I have to cache this information, but first let's try to call it somewhere. I can get rid of this and this one, and instead of here I can say user service await const get user function. I can then call it, and I can say user one. I need the information from user one, and actually I have the user one in my Redis cache, so you can see user one is here with some data. Let's get it. Wait, now I have this user, and if I try to render it somewhere, maybe user.name, it should be fine. Let's see what's wrong. Yeah, it's complaining about this part. I can copy the same logic here, and instead of that I can say user.name, maybe h here. Okay, as you can see, I could successfully call the API, but if we take a look into the console, okay, I don't need this server anymore. I will get rid of it, and let's refresh. If I refresh, you can see that it's calling the API or the querying the database twice, which is not something that we want. We want to optimize it and to have one request to our database to query once. And to do so, we can use a cache from React. I'm going to implement the cache in my service here, user service, and this get user service should call the React cache. And if you're not familiar with the React cache, it's a function that will cache the output of functions for you. I can import it from React like this, and then over here, whenever users try to get some information, instead of calling the API, I'm going to call the cache function. So I have to cache the same thing over here. I'm going to call this and cache it. Let me try. Const cached data would be cache async TID. I trust this copilot, and then it's going to return something. Okay, I will say what's going to return, but now I'm going to do so like this. I'm going to call this API in my function, and now I'm going to use this cache here instead. I'm going to pass this ID to cached data, to cache data function, and return it instead. So over here, it should work now. As you can see, it's working actually. And if we take a look into the console.log to see how many times it's going to query, let's refresh. It's calling it twice, and the reason is that we are instantiating this user service multiple times. So this cache also is going to be instantiated multiple times. It's not one instance. And to fix that, what we can do, we can just instantiate this service once somewhere, probably here. We can do it const instance of this user service, and I can export it. And if I use this one instead, it's going to use the same cache here. Let's try it. If I go to page again, and here instead of calling this function, I can simply say get this from this user instance, and the same here. Now I'm getting the same result, but this time I'm expecting to get the data from database only once. And as you can see, it's working as expected. So I just wanted to explain another pattern that we can use caching to have same data at several places in your application. It is in here next to my page, but imagine it can be into another file, and it can be rendered into another nested component, and this component is going to have this data. So it's totally fine to query since it's cached. It's not going to affect the performance, and it's recommended by Next.js as well. All right, next topic. What if you have some source code that you don't want to leave the server? You want those source codes or those codes to stay on the server and never be transmitted to the clients. Maybe there are some logics, sensitive logics, and you want to keep them there on the server. And there are two ways that you can implement this. First, you can use another directive called useServer. Let's have one. So I create a component here, underscore component, then maybe a button. Then I can create a simple component. I'm going to return a simple button, but I'm going to use client. Okay, now imagine I have some utility functions, somewhere that I want them to be on the server. I can call it like utils, and then a function like, I don't know, add.ts, export const add. This is fine. And okay, first of all, if I import this add like this and use it somewhere, maybe I should render it here. Now if I render this button on the page like this button, you can see, probably I have to move it down so you can see it better. The button is here, and you can see there's a tree, number 3, and this function is called on the client because we are saying that it should be a client side component, and it's going to call this function on the client. So it's going to send this function to the client. The browser will execute it for you on the client. But we don't want this this file or this function to leave the server, and to do so, what we can do, we can use the use server directive like this. It's again like in contrast of use client like this, use server, use server. And as you can see, it's giving me an error because use server functions should be of type async. So I can say async here, and it's going to return some promise.resolve, maybe with a value like this, and it's fine. Now I'm getting an error. Let's see if I take a look into the console. Maybe I run it again. Okay, now it's fine. And here what's happening is that we are calling a function from the server, not a function that is transmitted to the client. We are making kind of a request to the server from the button because we are importing something from the server, and this function is going to be like called on the server from the client. And to prove that, we can take a look into the network tab as well. If I do go to the network, if I refresh, you see a lot of things here, but something that I'm looking for is here, this local host, which is a post of type post, and it's calling for add.ts. If we take a look, let me zoom. Probably I have to detach this, and this is a request. Again, its type is post. It's not the first one, the first get. It is a post, and the purpose of this call is to get that number, to call that function on the server, which is the add, with some parameters that we are sending. The parameters are here. You can see the payloads we are sending from the client, but the execution is going to be done on the server, and the response would be here as this tree. As you can see, this tree is the response of that sum, and this is done on the server, and we get the response from this function, and Nextjs is taking care of them. Later in the server action, I'm going to explain more about them, but in general, this is one way that we can keep the source code on the server and prevent them to be sent to the clients. The second option is by using a package called server only. So if we try to install it, npm install server only, and now that I have this server only package, I can use it in my modules. For example, here, instead of using this directive, you can use it as well, that's fine. But if I import that server only like this, if I try to import it from a client component, like what I'm doing here, so I'm having this button, which is a client component, and from here I'm importing something which is server only. This is going to be an error. Let's try it, but not in the build time, but at the runtime. npm run dev. If I refresh, I'm expecting an error to appear. Let's do it. And as you can see, it's giving me an error that indicating that we are importing a component that needs server only. But we are here in the use client, which is a client component. This is another way, maybe a layer of security. If you want to make sure that first of all, users or developers by mistake won't be able to import something from the client components, you can go with this package. And we have similar package. This is server only. We can have another package called client only, and that does vice versa. It means if you have a client component or module and you want to import it to that server component, it's going to raise an error for you. Another concept that we usually use in our application is how to handle context providers. And since context providers should be used on the client, and usually we wrap the entire application sometimes with the context, we have to make the place that we are using as a use client, but we don't want to do so, right? For example, I want to wrap their root layout with the context provider, and usually what we do is like we create first of all a context, like here, export or not export, const maybe theme provider. Then I create a context from React, and this theme provider can be used inside this place, and also I have to close it, the provider. These context providers that we are creating here and we are consuming, we are using them here, is to require use clients, but I don't want to use use client here. If I do so, I'm going to like send everything to the clients at the top level. But there's another pattern to fix this problem. So first of all, I get rid of this context provider here, and also get rid of this use client. So I create a context somewhere else. Maybe in the app folder, I create a folder context or providers like this, and then I say theme provider. You might have different things. Export const theme provider would be a create context from React with the default value. For now it's not, that's fine. Or I can go with maybe dark. Export const theme provider, my mistake, return theme provider, like this. And what we have to do to render children as well, like always, children, and we have to get these children. Let me copy because okay, and this children is going to be of type React Node. That's fine. All right, now we have this context, but it's created in a separate file. Now it's safe to use client here and to use it in my layout or wherever I want. Context provider, it was theme provider. And now the way it works, since we are using, wrapping the entire thing with a use client component or a component which is a client side, it's not going to serial or send everything, all the components or pages that I have to the clients. React is smart enough to only send those required files or required chunk of codes to the clients. It's not going to send everything because we are wrapping everything with this context provider. And the way that context itself works on the server is that here it's going to serialize all the properties as that payload that I explained at the beginning of this video to the clients. So also you can have this kind of like fetching functionalities in the layout. Probably you might have you might want to fetch some data, and you want to pass this data to the context as value. If your context receives these values, mine it doesn't receive, but it's totally fine to get some data on the server and pass it to the context at the root level or at the page level, doesn't matter. And this is going to be serialized and passed to the client, so they can, or those client side components, since they are the only target of using context providers, they can use this data which is passed on the server to the context provider. So let's try, let's see if it's working fine. And usually we export something as well, like here, use theme, a hook that uses this. I have to say use context, use theme, use context like this, and I have to import it. Sorry. Use context. All right. If I try to use this hook in my component, maybe in the button, const theme, use theme. And if I try to like maybe show it somewhere, you can see click me dark. The dark is the current theme that we are getting from the context. So the context is populated on the server, and data is serialized to the client with the React Server components, payloads, and now in the client-side components, we can use those kind of patterns that we usually have and consume the context provider data. And actually, the same situation you can have for other things, not only for the context provider. As I said, we can populate, we can get some data here and pass it to the context provider, and it's going to work for other kind of client components. For example, imagine my button receives a property, like, I don't know, some data like this. It's fine now. And the user, that maybe the one that is rendering this button, should pass some data. In this case, I'm passing data from the server. So if I get maybe this user information and pass it as data, here maybe I go with name of the user, you can see that data is now sent to the client from the server. So I get the data in the server from somewhere, so some data source, like in this case Redis, and I'm passing the data as props or properties to the button, to the client side component. And in the client side component, we are getting that data and we are consuming it. If you take a look into the React Server component as well, you can see that this button is receiving those information. Maybe I have to find it somewhere over here. Yes. If let me refresh, I believe I'm refreshing, doing something wrong. Okay, this one. If you scroll down, these are those React Server component payloads. As I said, this button, I'm expecting something like Alex inside the button. Yeah, inside the button component. Let's see if we can find it. Alex, if I search, you can see, okay, first of all, this is the H1, and if I look for another one, yeah, over here probably, as the data, I'm passing Alex to the component. So it means that the data that we are sending to the clients from the server is serialized somehow in this format, in this JSON format, and built in this React Server component payload, and it's accessible from the client side components.